So since I could not be in class today, I decided to make you guys a video, maybe a couple. I like to try to keep videos under 5 minutes. So there might be 2, but I'll try to keep it quick and concise. Before you move on though, to take any notes, please go ahead and pause the video and title your notes so that you can refer back to them and find them when you need to. All right, so if you remember, just a quick review, variable on one side equations, and what we did on Thursday to start off Unit 1 was we said, well, okay, we've got Unit 0. The Unit 0 material was just to simplify an expression. And to convert Unit 0 to Unit 1, we just added an equal sign and put something on the other side of the equal sign. So that makes it an equation. Started with expressions, ended with, and we're continuing now to simplify expressions, but then we're also going to be solving for the variable. So if you remember what we talked about, we decided we would go ahead and combine like terms, but first we want to get rid of these parentheses by distributing the -3 to both terms. You might want to pause the video and see if you remember how to do a problem like this, where when we distribute -3 to the x, we get -3x, and distributing the -3 to the -1, we get +3, and we still have the equals 10. Well, combining like terms, we notice that there are 4 terms on the left side, 2 terms that have an x in them, so 2 variable terms, and when we combine the variable terms, 4x minus 3x, we get 1x. And then we also notice that we have 2 non-variable terms, 2 constants, and when we combine those, we get 2 plus 3, which is 5. And so simplifying the left side means we get the left side as simplified as we can, where we can't combine any more like terms. And once we do that, we then use, if you remember, we talked about using inverse operations. So we use an inverse operation to undo what's being done on the left side. So because we have a +5, we subtract 5 to move the number terms to the right side of the equal sign. So 5 minus 5 is 0, and we're left with an x on the left-hand side, and 10 minus 5 is 5, and we have isolated the variable, and we are done. So that's a quick review of what we did the other day. And you had plenty of practice problems from pages 72 and 79, which I had forgotten that we wouldn't be meeting on Monday, so we're going to be meeting Tuesday, but since I won't be there, then we'll next class I'll have with you will be on Thursday. So anyway, on with the new material. What you're going to see today is variables on both sides. So I'm going to show you a couple basic equations, and then I'll show you more of what you'll see where you'll actually have to do some simplifying. So if we start with an equation like this, 5x plus 2 equals 3x plus 7. Let me zoom in a little bit here. I guess that's it. So what we notice that we have different than we did last week is there are obviously, like I said, variables on both sides. So the next step then, guys, would be just decide what side you're going to put the variables on and what side you're going to move the number terms to. And there's a very strategic choice that you're going to be making, and I'll show you actually a different problem at the same time, and so we can discuss why are we choosing one side over the other. Okay, so in this first problem, if you notice, if we subtract 3x from both sides, then on the left side we're going to have 5x minus 3x, which will be 2x. So therefore the variable term coefficient 2 is a positive number. Now, could we subtract 5x from both sides? Sure. But then we would have on the right side 3x minus 5x, which would be negative 2x. And I guarantee you will want to keep your variable terms positive whenever you can. So that's why in this first example, we subtract 3x from both sides. And when we do that, we have 2x plus 2 is equal to just 7, because the 3x minus 3x adds up to 0. 0 plus 7 is 7. And now we are back to a two-step equation, which we know how to solve those by performing our inverse operations. We get, didn't leave myself much room here, 2x is equal to 5, and then when we divide both sides by 2, we get x equals 5 halves, and I'll write that over here. So again, as you noticed, we moved the variable terms to one side and we chose the left side because the variable term then coefficient is a positive number. So 2 is a positive number. That's the variable terms coefficient. Whereas in the second example, you notice if we were to move the variable terms to the left side, if we did that, we could, and we would be subtracting 6x from both sides, but then 2x minus 6x gives us a negative 4x. So we would rather subtract 2x from both sides. Now, at the same time we do that, we can go ahead and, since we know we're moving the variable terms to the right side of the equal sign. Now, when I say right and left side, I mean of the equal sign. So when we move the variable terms to the right, we can also at the same time move the number terms to the left, just by, again, performing that inverse operation. So we have a plus 3, we do a minus 3. So that means we're going to be moving the constants to the left and the variables to the right. And then when the dust settles here, we have just got to be careful here. Minus 1 or negative 1 minus 3, or negative 1 plus negative 3. That's negative 4. And then we have equals 6x minus 2x is 4x. So we have divide by 4, and we get x equals negative 4 divided by 4 is negative 1. So I said I wanted to keep the video under 5 minutes, and now we're at 7 minutes. So I'll make another one.